Okay, well, thank you so much to the organizers for selecting our paper. So before I tell you anything about sovereign hold-up, or one of the most polluting industries globally, just a minute to take a look at the map. So what you see is in black, these are the countries that have a constitutional ban on retroactive legislation, on non-criminal retroactive legislation. So the government cannot change laws outside of criminal cases, of course, retroactively. And the other countries don't. And most of the other countries don't. US doesn't. Most of Europe as well. France does not. Most of the OECD countries do not. So this is the canvas where we are working on this paper. I guess we try to provide a window onto what is the cost when the government can rewrite laws after firms have invested. And this is joint work with Alessandro Iaria at Bristol, Alyosha Jansen at Singapore, Clément Mazet, who's a colleague of mine at Bocconi and is going to move at HEC soon, and sadly enough, and Rob Perron in Australia. So just to motivate, we know that many some of the largest and most irreversible investments require a contract with the government. You can imagine resource extractions, infrastructure, private-public partnerships, and so forth. And at the center of these contracts, there is a problem, which is the fact that states, the government cannot bind future successors in most cases. And we call it sovereign hold-up. And the idea is that of time and consistency, a la Kipling and Prescott, but put it in the perspective of investments. And you might think, what is new compared to policy uncertainty, where some of you might have worked into? Well, policy uncertainty, my take is that this is about trying to predict what politicians will do. So it's whether a politician might or might not do something. Here instead is whether you can at all. It's sort of Knightian uncertainty, if I may. And the result is that, as I show, is firms underinvest in irreversible productive technologies. I'll be more specific about it. But I guess the key interest here is the following, that if adoption of a technology itself generates know-how, imagine absorptive capacity, that you have some soft skills that allows you to adopt more technologies or to innovate more, then this sort of hold-up is no more project-specific as we studied in industrial organization. It becomes broader because delayed adoption in one area arrests learning trajectories everywhere. And we can study this very nicely in the oil and gas industries because we have very good data. And in this paper, we're going to look how credible commitment from the government, exploiting quasi-natural experiment, mobilize know-how within firm that was sitting idle before inside the firm, and how the industry reshape afterwards. So let me, so I'm going to focus, this is a micro paper, so I'm going to focus on a specific technology. This is, I'm going to give you more details. This is called enhanced oil recovery, and these are frontier technologies in oil and gas. I focus on this one because the key tenets of hold-up, the key aspects of a technology that is subject of hold-up, is that it must be large and fully irreversible. There should be a long payback. I pay today, and the returns come sometime in the future. And this is very asset-specific. I cannot resell it. And this is the characteristics of offshore enhanced oil recovery, because the cost of these technologies is in the order of $500 million to $2 billion. The payback is the longest in the oil and gas industry, about 10 years. And it's very asset-specific. We are talking about drilling a well in the middle of the ocean. Once you drill, it's not that you can sell the well to somebody else. And moreover, it is off the shelf. You call Ali Barton, they come on spot and they do it for you. So we are not going to talk about R&D. We are going to talk about adoption. The know-how is about when decided to adopt or not. And here is the census of all the EOR projects. So you see that it has been booming, and part of it is the shale gas. I'll comment quickly shale oil, about it. But most of them, as of today, 437 projects are onshore. This is an order of magnitude much larger than the ones that we see offshore, and this is because the onshore projects are much simpler. They cost 3 to 5 times less than the offshore ones. And our focus is where we have, where we're going to have our post-natural experiment is around 1980s in the North Sea. And these 7 projects that you see globally, 6 of them were in the North Sea. So the North Sea is really at the frontier. This is where all the innovation were adopted back then, and we observed basically the universe of this technology. The experience, what I'm going to show you is very simple in the end. I'm going to compare UK and Norway, but there is an imaginary line that separates the geology of these fields between what's on the one side of the North Sea, what's on the other side of the North Sea. And so the geology is rather similar. You can see that this is the adoption of EOR, 1 field in Norway all the way to 1985, and five fields in the UK. What happened in 1985? We have a Norwegian Supreme Court decision which barred unilateral retroactive license changes in Norway, but that didn't happen in, of course, has no impact on the UK. So in UK, which retained parliamentary sovereignty, we see these unilateral retroactive laws taking place and shaping licenses in this period. And then you see that over time, this is the adoption that went from 1 to 9 in Norway. So yeah.
If you had a theoretical framework in mind, would you kind of Williamsonian framework? And in one case, you can commit in advance to the sharing rule. In the other case, you cannot commit to the sharing rule. Is that the thing?
I'm not going.
I want to locate next to a plant, but then I have a hold up problem because I depend on that plant, and that plant can change the sharing rule exposed or whatever. In the other case, you can commit. Is that the idea?
I'm going to show you some empirical evidence around that direction. The theoretical framework that we have is very simple, and it's mainly to motivate the empirics. It's just you are endowed with a field, and you decide whether to adopt or not, and you are exposed to this shock. But that is the idea.
The idea is that you avoid underinvestment.
Yeah, exactly. So that's the paper indeed, and so what we find is credible commitment unlock adoption and production. We see that firms that were more exposed to these EOR eligible fields in the pre-period adopt more, kind of doubled the adoption in the post-period, and production rises, and with it market shares. It's not a story of being state-owned. You know, we know the history of Statoil, and it's remarkable in Norway. It's not a story of state ownership. It's a story about being the firm inside the equity holder of an oil field that is the one who's responsible for adopting the technology. So if I was the one who was responsible for decisions in an oil field, then I'm the one who makes more of these decisions also at other fields. So it's know-how. And we show, and I think this is the interesting thing, it goes towards your point, we show that then if you adopt more, if you were exposed to technology and you have more know-how, then you end up diversifying your production into related extraction technologies. So that is a path dependence. Learning the case with technology distance. You have a larger array of extraction technologies compared to other types of technologies, exploration technologies. Okay? So we complement, several strands of literature. Here we link the old up literature of Williamson with institutional quality. And here what is remarkable is that oftentimes institutional quality is a bundle. And here instead we can, separate an aspect of quality, which is credible commitment. There is, of course, literature on legal system that provides credible protections of formal rights and their importance. And this credible protection here is a form of industrial policy. Because by tying hands, firms are more willing to invest and acknowledge the market failure of knowledge is not deployed is solved. And finally, there is a literature on technology adoption, absorptive capacity, and for capabilities. And some of you have got some work here. And here we show the sovereign hold up, arrests the deployment of absorptive capacity, and commitments instead unlocks it. So the talk is standard. I'll show you first some settings, so geology, technology, legal. Then very quickly I'll show you the model, which is mainly to motivate empirical analysis, so I'll be quick. And then I'll show you a bunch of results before jumping into the mechanism, and then we zoom out and see more about this global relevance of using constitutional data. So this is the map of our data. We draw data from Wood Mackenzie, which is an incredible company that collects this information for each oil fields globally. And we purchased data from the North Sea. And here you see 426 fields in UK and 95 fields between 1975 and 1995. We observe all their ownership, all the capital expenditures, all the operative expenditure. We observe their geology. We know basically these are data used by Goldman Sachs or any other investment banker. So we know anything that these people know when they end up selling oil fields. This is basically 96% of total production of the North Sea. You should think that these firms have no market power. These fields have no market power. Back then was basically 8% of global oil production. So this is not the OPEC that if you adopt a technology, you take into account the fact that the oil price will change. Okay, so what is this technology about? So you should think about an oil field as a Coca-Cola can. You open up and Coca-Cola comes out. That's the first primary natural pressure. You can recover 20% of Coca-Cola. After that, you need to kind of stick inside something else. For instance, water or gas flooding. It gets you to 40%. Tertiary recovery is injection through mainly gas or CO2 and chemicals, and this is mostly the offshore bit, or other stuff. And so basically, so you need some infrastructure. You need to inject inside the reservoir. These things will break the stones and increase pressure, which will come to a separator, and you separate the chemicals or gas from the resource that you want to collect. So you're going to need investment in the middle of the sea. You need a tank. You need to purchase these chemicals. And the only bit I'm going to tell you about that is green is that people are proposing this technology as a way to make our gasoline cleaner, because we can capture CO2 and inject it in. And we have some preliminary evidence that says that no. We are extending the life on oil fields by way so longer than what CO2 you put in. So, but that's, I'm not going to talk more about that on this. So this is what happened. So in 1972, the Norwegian government was thinking, why don't we have, there are so many royalties, and the royalties interest rate accrue on the bank account of the firms because they pay once every 6 months. Why don't we make them pay once every 3 months? And why not, since we are thinking about it, why don't we do it retroactively? So that was the policy, 1972. And Philips, which was the operator of one of the biggest oil fields in Norway, was like first complying, and then was like, you know what, I file lawsuits because there is a gray area here. The Constitution says that you cannot do it, but some policies have passed, some policies have not in retroactive laws in Norway. So the matter got to the appeal court, and finally the Supreme Court decided that the state cannot revise licenses retroactively. And then all the other operators file lawsuits right after. This is probably December 24th, and this is January 1st. UK, these are 3 laws that changes license retroactively.
So when after 1996, did the state have to give a load of money to the...
Yeah, but honestly, the money was just the interest rate that was collected, right? So there was that difference. But still, it's mainly a change of the legislation that now you cannot change royalties retroactively, and now it's written.
Also financial.
Yeah, there was also financial, but it's not huge by today's standard. It was mainly safety in the regulation. So it's an asymmetric shock to incentives. So the empirical strategy, we think about a dynamic model a la Jovanovic and Jarko, way simplified. So I'm going just to skim through it. Imagine that in each period you are endowed with an oil field, and you can decide whether to pay a sunk cost in order to adopt a technology that gives you a payoff, delta pi. And the success probability of this technology depends on your know-how, which is a state variable that varies over time. It depreciates, but if you succeed in adopting the technology, then your know-how increases. So this gives you a Bellman equation where you either do not adopt at any point in time and you get your share, because many firms own one oil field, so your share on the profits, revenues minus the cost time, the continuation value, and your know-how depreciates because you're not adopting anything. Or you adopt, and so you get your profits plus, if the adoption is successful, you get the extra kick. And then you have to take into account that if you adopt successfully, the state variable updates. So this is kind of complicated, but there is an optimal policy threshold that says if A, your know-how is larger than a threshold, then you should adopt. And so here we have a policy shock that changes the extra payoff because it's safety in the investment, in the returns from the investment, in Norway compared to the other fields. And so instead of structurally estimating this problem, because it's impossible to think what the know-how of Shell is, one contribution of the paper is to show how you can transform a dynamic problem into a simple difference in difference. And the difference in difference that we're going to estimate is what is the share that firm I had in EOR eligible fields in Norway, so that's exposure, before 1985, time a post-dummy, so before after, and controlling for the share of EOR eligible fields in the North Sea, time a post-dummies. And what we can show is that under parallel trend, gamma 3 recover the causal effect of the ruling. And we can do this same analysis at the field level, not just at the firm level. At the field level, we know which fields are eligible, so we don't need to aggregate across compute shares. So enough for, I'm just going to show you some results. Here, EOR adoption increased, say a 10% increase in exposure in EOR eligible fields that you had just by chance before 1985. Leads to a 2.3 percentage point more adoption, which is basically 30% above the mean. Okay, that's a substantial increase in adoption. Cumulative capex, we had similar results with capex, capital expenditures. We see that increases because you are adopting an expensive technology, and increases by about 23%. And now what we may ask is, this policy is not just about enhanced recovery, it's about anything, right? So these firms that perhaps were more advanced, have they diversified more? So we can compute some measure of diversification across the technologies that they have, which observing the data, and we can see that these firms actually do not have a broader array of exploration technologies. They do not have some more extraction technologies. They are not in a broader array of well according to the depth or reservoir sizes. So it's not a story about having ownership at all in the field. It's about operating, making decisions. I'll show you in a second. So another thing that comes from the model is that if you have a higher share in a field, you drive more, you internalize more of the value, right, of adopting new technologies. And so what we can see is that when we look within fields, fields that have a higher share, the operating firms, the firm that makes decision at a higher share, are more likely to adopt. And then we can ask, is there something specific about the firms that are in Norway versus those that are in the UK? And we have a set of firms that are on both sides, and we can check adoption by restricting to this sample. And we find that effectively the same results. So we have more adoption in EOR eligible fields, and we find increased production. Some pre-trends that look nice, but I'll skip to basically what happens in the market. So in the market, we see an increase in production, as you might expect, because this is a productivity enhancing technology. So the firms that had more EOR start producing by about more 30%, 38% more. And they see an increase in market shares. What is really interesting is they start expanding their portfolio. So we see more these firms having more fields, but not only in EOR eligible fields, but also fields that are not eligible. So you need different technologies. And then this opens the question, what is the mechanism? Is it the government that is driving this, or is it this know-how create some soft skills that you might want to diversify more? And to address it, we just take our regressions from before, and we just add some heterogeneous effect. We know which firm operated an ORC field that adopted EOR before 1985. You should think about this. I didn't say. You should think about an oil and gas field as an apartment building. There's going to be many families, but just one of them decides when to change the elevator. Okay? So if you were that family, then you had the knowledge and you have that expertise. You have some state-owned firms that were state-owned in the period. And so we have three groups. We have firms that are state-owned and that also operated an EOR field before, Statoil and BP. We have firms that have only know-how, Colloque, Mobile, and Shell, and we have others. And so what I can tell you is that with respect to production, you see completely different trends. Like state-owned firms wanted to beef up their balance sheets. And so they start producing more. Non-state-owned firms do something different. Their production doesn't increase that much. Above the baseline, right? It increases, but not that much. And market shares increase just much less compared to the state-owned firms. But what is striking is then instead what happens in terms of their portfolio. The private firms invest basically twice as much as non-private firms by expanding their portfolio. And not only in EOR eligible fields, these are fields that produce immediately, but in non-EOR eligible ones. So there seems to be a story where you diversify and you learn something and you put it in different places. And we can take advantage of this really nice data set that records like how a platform is constructed, what type of injection well you have, what type of, anything you might, what type of extraction technology, what type of exploration technologies. So we can check a diversification in terms of 1 minus the concentration index of different technologies by firm. And what you can see is that the private firms that have the private expertise start exploring much more compared to start having a broader array of exploration technologies compared to the other one. But the striking difference is in terms of extraction technologies. Government firms realize that they can do EOR and they just do one thing. The other firms expand and they do other stuff. And we find this difference also in the type of fields that they end up with. Different arrays of well depths, different arrays of reservoir size, and also how much they engage with tariff intensity is basically how much infrastructure you use, how much gas you buy from onshore to offshore, how many times you call Halliburton. And capital expenditure, much broader array. So they have both fields with very little capital expenditure and fields with very large capital expenditures. So this is what happened then if we zoom out. This is the trend in UK in the share of risky fields where deep, sour, and either deep or sour heavy fields. And you see this was the trend. And in nothing, if the policy didn't, if the Supreme Court were to make the decision, then we would expect this to be the share of risky oil fields to be developed in Norway. Instead, we see a much larger trend. And on the average, still at the macro picture, here I'm comparing the average number of exploration technologies, and you see that before per firm, before 1985 was basically one technology per firm in UK, and many more in Norway, and many more in UK. You see this trend diverse. And extraction technologies diverse right after. This is because first you explore and then you extract. So what is the global relevance of this? And then I'm going to conclude. This is the map I started with. So we, thanks to this project, which is the Comparative Constitution Project, they have all the constitution globally, and we just run an LLM on all of them just to check which countries, like Norway in black, have similar policy. And we were surprised by this fact that many countries actually don't have it. And of course, enforcement is another thing, because Russia is in black, and expropriation might be, we hear stories these days with defense investment and the oil and gas industry as well in Russia. But this is, in terms of the legal aspect. And here are a bunch of examples. Like in France in 2021, there was Article 2025 Loi Financière, that cut solar feed-in tariff by up to 80%. Of course, Italy must be in the list. We did something similar. Spain did something similar. UK, US, Trump administration canceled multi-year NSF grants already awarded. And I think, there is space to think about this question of how we write policies and how it impacts firms or researchers and their diversification path. So that was to conclude. The core message of the paper is by tying the stained ends, the 1985 ruling turned promises into credible commitments, and this decision was effectively an industrial policy which unlocked technology deepening and kind of reduced the extent of a market failure. Thank you.